Hi, my name is Jim Cowart, and I would like to take a few minutes to talk to you about postal.js xframe demo app. You can pull the code down if you're interested by going to github.com/postaljs/xframe-demo. You'll need Node.js and npm to get everything up and running, so once you've cloned the project, run npm install in the directory to get your dependencies, and then when that's squared away, you can run npm start to run the app, and then browse to localhost 8080. You should see something along these lines. So what is all this? To give you some background, postal.js is a JavaScript message bus implementation. It runs in the client as well in Node. Postal.xframe is an add-on that allows you to bridge or federate multiple instances of Postal. But why in the world would there be multiple instances of Postal present? A good scenario would be if you're in a parent window and you have an instance of Postal running and there's one or two iframes that also have instances of Postal, or a web worker that has Postal running. It'd be nice if you could connect them up so that components really won't care about where they're located. They just care that they get the messages that they're interested in and can publish the messages that they should. So something could get published in the parent window and then republished in the one of the iframes, or all the iframes for that matter, if it were supposed to, and it would be published as if it had been published locally. So components in the iframe wouldn't care that the message may have actually originated in a remote window or in a worker. It just knows that it got a message it was interested in. So xframe provides this functionality, and you do have a decent amount of control. It's not just a fire hose of all the messages being shared. We'll see here in a few minutes that you can actually fine-tune which messages are allowed in or out or both. So the idea with this particular demo is we're going to have a parent window with 4 iframes that it federates with, and 3 of the iframes are visual widgets that we'll see that are going to display some search results from Twitter. And then the 4th iframe is hidden in the background, and it's a communication iframe that just handles talking to Node. So it's kind of overkill on one hand. It's not your typical everyday scenario. But at the same time, if you've ever written, say for example, third-party widgets that are going to get embedded on a site and they have real-time communications involved, so there's a socket connection or of some kind, right? Well, what happens when you have n number of widgets that particular person may use of yours and embed on their site? You don't want each widget opening up its own socket connection. That would be a recipe for scale fail. So what if they could share a common communication pipeline? That would be cool. Or what if they needed to talk to each other, and even if they didn't need to share a common communication pipeline, say they're just using HTTP, but they know the other's present by detecting in some way, wouldn't it be nice if there was a higher level API that kind of kept you out of the pain and infrastructure of window post message? And especially in a more complicated scenario where there's some more in-depth interactions, that's when post message starts to show some strain. Another scenario too would be, let's say you have intensive processing that you'd like to move out of your parent window into a worker or an iframe, depending on what your situation is, and you'd like to just continue for messages to be exchanged like they always have been. So if you have something like Postal in use and you can put xframe to help bridge worker to the parent window or iframe to the parent window, your components can continue to act like they always have, consuming the messages that they consume and publishing the ones that they produce, and never know the difference that they were moved or that their publisher or subscriber was somewhere else. That's the beauty of being able to bridge and federate and write location transparent code. So the search in this case, you can see here at the top right, we've got a JavaScript default search term, kind of cheesy, but that's what we're going to do. And then this is going to kick off a search once I click initialize. On the Node side, it's going to hit a Twitter HTTP API search. So we're going to get results back, kind of munge them on the Node side, push them down over socket.io to our hidden communication iframe, which is then going to publish any messages that it's concerned with out. And since the parent frame or parent window is federated with this communications iframe, it's actually going to receive some of those messages and continue to pass them on. So let's see this in action. So you can see our widgets are initializing. Once the Node service starts returning results, we can see that we've got some data. So let's talk about what each of these do. This widget at the top left is using Raphael.js to provide a pie chart breakdown of the percentage of languages represented in the search results. And you can see about every 10 seconds or so, the Node side will push down additional results. So you see these percentages change, and you'll see the hashtag word cloud get updated with more hashtags that are represented in the results. And this is using a Canvas plugin that someone else wrote, and it's also using Knockout.js to keep everything up to date in real time. It's just for fun. And then on the right here, these are the actual tweets that were in the results. And they're sorted in the order where the most recent's at the top. So it's currently actually building back history. You can scroll down quite a ways. But once it's exhausted as far back as it can go, you'll see additional tweets show up at the top as new tweets are indexed and added to the search. So that's Backbone 2, by the way. This particular widget is Backbone.js, sort of Frankenstein Backbone. But the idea is each component is simply listening to the message bus for its information. Instead of using Backbone Sync to make HTTP calls, in this case we're actually tied into a message bus. And instead of Knockout using jQuery Ajax or anything like that, it's actually listening to the message bus. And the same with this guy here, the Raphael.js pie chart. So they could all live in the iframes like they do, or they could live in the same page together. It doesn't matter. They'll continue to function the way that they always do, as long as they get the messages that they're interested in. So how does that work? Let's look at our communications iframe so we can see really kind of the boundary at which point the server information reaches the client. So let's look at com main. Now this is the main.js file that gets kicked off in the hidden communications iframe. And this is an AMD project, so these are all AMD modules. Feel free to source dive. There we go. So let's talk about what's in this guy. So at the very top, we've got a detection script that's looking to see if we're in a window or if we're in a worker. So in this case, we know we're in an iframe, so it's not going to pass the test to see if it's a worker. But it is interesting to note that this is really all you need to test to see if you're in a worker and import the scripts you need. So we'll see that run as a worker here in a few minutes. But in this case, it's an iframe. We continue on loading up all the requires bits, and we get socket.io and postal.xframe, and once we have that, we have what we need to start kicking off our configuration. So in the case of federating, if you're on a network, you've got to have a way to be uniquely identified, right? So that's what the postal instance ID call is for. I'm assigning this instance of postal in this communications iframe the instance ID of com. I mean, I could have had the server pass down a GUID or something like that, but in this case I know that there's only going to be one com instance, so that's what it is. The next call is postal.fedex.addFilter. So the FedEx namespace under postal is actually where most of the top level federation APIs are available once you start using Postal Federation. And the addFilter call allows you to specify channel and topic bindings that you allow in or out or both. And the default filter mode is whitelist, which means the filter has to be here to be whitelisted. So if you don't provide any filters and you're in whitelist mode by default, nothing will cross the boundary to another window. So that's just kind of being safe by default. You can set it to blacklist mode and publish all the things if you like. I don't recommend doing that other than playing around, because that could get very chatty, including local like postal system messages would get published across, so I don't recommend that. So in this case, you can see that we're using channel and topics. So if you're familiar with postal, you know that the topic binding semantics kind of follow the AMQP wildcard bindings. So we're saying, hey, if I get a message on the control channel with any topic, I'll allow it in. So a remote window to this guy publishing that channel and topic would actually succeed in getting the message into this frame. And then these messages are allowed out. So if this frame publishes these messages, they'll be allowed out over the X-frame bridge to other windows that are interested. So down here, we're listening to socket.io events. So if we get a search started event, we turn around and publish. On the channel search, we're publishing a started topic, and you can see right here that we allow that message out. So that's going to publish up to the parent window and potentially onto the other iframes. And then this postal batch event under socket.io, I happen to know, is bringing an array of postal envelopes that were created on the Node.js side. And I'm going to iterate over those envelopes and republish them here locally. And I happen to know that these are the channels and topics that will be involved in whatever we get in that postal batch. So these messages will also be passed up to the parent window if the parent window is allowing these in. So that's the gist of how the communications iframe basically becomes the entry point to broadcast out to any other interested parties. So the parent frame will be up here. And you can see that it's allowing language stats, hashtag stats, and search. These are the things that the com iframe will publish up. It's allowing them both in and out. So that's kind of cool. So as the widget iframes that have the pie chart and our Twitter timeline and our word cloud federate with the parent window, they will specify which one of these channels they're interested in letting in. And that's ultimately how the messages arrive at their recipient. So it's kind of this infrastructure configuration via adding filters. The only other thing that we see happen both here in the parent window and also in com main is this idea of signal ready. and that's the local instance of Postal's way of telling anything else that's out there, hey, I'm ready to federate. And there's a handshake that happens, in this case over post message, that allows them to connect up and share, this is who I am, this is my ID, and so on. So that's the gist of federating. Now we have this detection script to see, can this thing run in a worker? And if you have a browser that supports dedicated workers like IE10, Chrome, Firefox, Safari, you should be able to run this. So let's check that out. You can hover over the XFrame demo title and click on it, and that'll take you to worker HTML. This is the exact same demo, except we're not using the communications iframe anymore, the hidden iframe. We're actually using a worker. So big shout out to my friend Brian Hunter. We'll search for Erlang. You can see our widgets initializing. As soon as we get some data back, there we go. So as the search continues to get more Erlang results, we'll see the pie chart get updated, the word cloud get updated, and so on. But let's look at the code involved in getting the worker to spin up. It's really not terribly much at all. So worker main is the script that kicked this off. I'll give this a second to render. I am running MacBook Air, so pegging it to the limit at the moment. All right, so we can see right here we are creating an instance of a worker. We've pointed it to our com-main.js, which in this case it will pass this test now, so it's actually going to import the required JS library. That will thankfully give us everything we need to continue reusing our AMD modules. None of the assets in this stack actually need a window object. That's why this works. Obviously you can't use a worker if you're going to be touching the window in this case. But we see we're setting up the instance. We publish a message to start it. And this is the long way. So the worker support in XFrame is very young. I plan to give quite a bit of TLC to the API. But this is the raw base underlying API that you can call to tell XFrame to listen to this worker's message events. And then we signal ready. If you pull down the postal.xframe repo itself, you'll see a much more trimmed down example page, but it actually has alternate usage. And it's possible to actually pass the worker instance to one of the overloads of signal ready, so that would actually wire up the listening bit in the background and then also signal ready to that worker that we want to federate. So this is just an alternate way to go about it. But that's the idea. Works the same. None of the widgets care that we changed from a hidden iframe to a worker. All they know is that they get the messages that they're interested in, and they work. So I definitely encourage you to pull the code down. This is a living example. I definitely plan to morph it over time. So if you have thoughts on how things could be done better, or if you're doing this kind of work where you would like to move things into a worker to offload some processing, or you're writing third-party widgets and you need a good abstraction around the window post message API to something that's a bit higher level or more messaging directed, I'd be interested in hearing what kinds of experiences you run into and what your needs are, because I'd love to be able to help postal.xframe to meet some of those needs. But thank you very much for your time. Pull this down, play with it, and check out freshbrewcode.com/Jim Cowart, and hopefully you'll see some more blog posts on XFrame in the future. Thanks for watching.